All right, guys, here's section 1.6. Our compound inequalities and absolute value inequalities. We are in section 1.6, and this is on page 43. So if you're, I'm sorry, 41. This is on page 41. This is the example on page 41. So this unit, we're solving lots of equations. Compound inequalities, which is what we're going to do here, which is an and equation. Absolute value inequalities, which set it up with our center. This is actually supposed to be R. We set it up with our center and our range on either side. The only thing that's different is going to be the fact that it's an absolute value inequality, which affects our answer. So let's go ahead and get started. So when we're looking at this, if I cover this up, I have an equation. And if I cover this up, I have an equation. So rather than separate it into two equations, we'll just look at it this way. How do I get y by itself? I'm going to add 7 to this side. 8 plus 7. And then how do I get y by itself on that side? I'm going to add 7. So I get 23 plus 7. So I just kind of solve for the middle. And then I'm going to add or subtract or divide to both sides. So if I clean this up, I get 15, 3y, and this is 30. Okay, now I know I can divide this by 3, but if I divide this by 3, I have to divide that by 3. And if I divide this by 3, I have to divide the right side by 3. So then we get 5 is less than y, which is less than or equal to 10. So if I put that on my number line, if I put a 0 here, and I go 5, and I go 10, this is an open circle, this is a solid circle, and y is in between both of those. That's what my answer looks like. So again, solve this thing like one big long equation. It has a left side and a right side and a middle. Whatever I do to the middle, I have to do to both sides. So here I added 7 here to get rid of that 7. So that means I added 7 here and 7 here. I need to divide this y by 3 to get the y by itself in the middle. And since I divided by 3, I divide the whole thing by 3. I divide the 15 and the 30 by 3. That's how you deal with and inequalities. So let's look at this here. Let's look at 6y minus 5 absolute value greater than or equal to 13. All right, so here we go. We're looking at this one. If we notice, we're in the form that we were in the other day. Center with a range, which means I have a range to the left and a range to the right. But we've got to tackle a little bit differently because of it's an inequality. All right, so if I put this piece here, I get 6y minus 5 is greater than 13. That's, actually, you know what? I'm going to move that over here. That's my range to the right. So 13, 6y minus 5. This is my range or distance to the left of the center. That means that it's 6y minus 5. And I'm going to make this a negative. But since I create this as a negative, I have to flip the inequality. Okay? So my distance is now for the negative, but my inequality flips the other way. Now I just solve them from here. Add 5, 6y is less than or equal to negative 5. Negative 13 plus 5. 6y is less than or equal to negative 8. Y is less than or equal to negative 8 over 6, or negative 4/3. If I look at this one, add 5 over, 6y is greater than or equal to 13 plus 5. 6y is greater than or equal to 18. 6y, oops, not 6y. Y is greater than or equal to 3. So now, I draw my number line, put my 0 here, I go over to 3 for my right side. I go over to negative 4/3, which is a little bit bigger than 1, because this is going to be negative 1 and 1/3. 3 goes into 4 one time. I have 1 left over. So either one works. Negative 1 and 1/3. And oops, yeah. That's a solid dot, and it's pointing to the left, so it's everything less than this. And this is everything to the right of that. Just shade to the right or to the left, depending on which way the arrow points. So this tells me my answer is less than 1 1/3, negative 1 1/3, or it's greater than 3. So or problems, you just solve either one. So that's how you tackle inequality ones. All right. So let's look at example 5. Example 5 talks about example 5, and it's on page 44. So page 44. If you read it, it talks about a 2-bedroom apartment that's $600 per month. So if I do my given down here, it's a 2-bedroom for $600 per month. So $600 a month. And so this here is my center. But she also finds out that they can differ by $225. This is dollars per month. So this is my range. And they want us to find the max and the minimum, or the range of what an apartment costs. So if I take this, I know that I have my equation here. X minus the center is going to be less than or equal to 225. So if I solve this, if I solve each of these, I get x minus 200, x minus 600 is is greater than or equal to negative 225. That's my left side. So my left side includes the negative. I have to flip the inequality. And then I also have my right side. I'm going to move this out of the way. Hopefully you guys wrote that. I'm going to use my right side, x minus 600 is greater than or equal to, nope, it's less than or equal to 225. So if I solve this, x is greater than or equal to negative 225 plus 600. X is less than or equal to 225 plus 600. I get x is greater than 375, and x is less than 825. So if I graph my range, here's 375, here's 825. So the cost of the 2-bedroom apartment, 2-bedroom apartment is between 375 and 825. So she can pay as little as 375, and she can pay as much as 825. So that's kind of how you do inequalities and absolute value inequalities, guys. Good luck.